In this problem, we look at several applications of compound interest. In Part A, we have $1,000 that's invested at 5% compounded monthly, and we'd like to determine how much there is after 8 months. In Part B, we want to have $1,000 in 9 months, and we want to determine how much we need to place in a savings account now that pays 5% compounded quarterly. And in Part C, we want to determine how long it takes to double our money if we invested at 6% compounded annually. In Part A, we're compounding monthly, so we're going to use our compound interest formula. A is equal to P times 1 plus R over N, all raised to the NT power. Here A is the future amount, P is our principal, or present amount, R is the annual interest rate as a decimal, N is the number of times per year we compound interest, and T is the number of years. So in Part A, we were investing $1,000, so P is equal to 1,000. We were told that the interest rate was 5%, so R is 0.05. We're compounding monthly, that's 12 times per year, so N is equal to 12. And we want to determine how much we have after 8 months. Now in this case, T is going to equal 2/3, because 8 months is 2/3 of a year. We plug in the values, we get A is equal to 1,000. It's 1 plus 0.05 over 12, raised to the 12 times 2/3 power. Will give us 1,000 times 1 plus 0.05 over 12 to the 8th power, which is $1,033.82. So if we invest $1,000 at 5% compounded monthly, in 8 months we will have $1,033.82. In Part B, we again have compound interest, but we're interested in the required present value. So we'll use the present value formula. P is equal to A times 1 plus R over N raised to the negative NT power. We want to have $1,000, so A, our future amount, is 1,000. The interest rate was 5%, so R is 0.05. We compound quarterly, so N is 4 times per year. And we want the $1,000 after 9 months, which is 3/4 of a year, so T is equal to 3/4. Plug these values into our formula. P is equal to 1,000 times 1 plus 0.05 over 4 raised to the negative 4 times 3/4 power. So that will be 1,000 times 1.0125 raised to the negative 3rd power, which is equal to $963.42. So if we invest $963.42 right now, in 9 months we will have $1,000. In Part C, we're interested in the time it takes to double our investment. It's interesting to note in this problem that we're not told the initial investment. And we'll see as we work out the solution that the initial investment has no bearing on the time required to double that investment. Since we're going to be compounding interest, we use our compound interest formula. A equals P times 1 plus R over N raised to the NT power. We don't know the initial investment P. We do know that our final investment will be twice the initial, so A is equal to 2P. We're investing at 6% interest, so R is equal to 0.06. And we're compounding annually, so N is equal to 1. We're actually looking for the time it takes to double our investment. So the time is unknown. That's the quantity we're going to solve for. If we put these quantities into our equation, we get 2P is equal to P times 1 plus 0.06 over 1 raised to the 1T power, or 2P is equal to P times 1.06 to the T power. At this point, we can divide both sides by p, and the p's will cancel. So we end up with 2 is equal to 1.06 raised to the t power. And here's where we note that the initial investment has no bearing on the time required to double the investment because we canceled out the initial investment. To solve for t, we're going to take the natural log of both sides. The natural log of 2 equals the natural log of 1.06 to the t power. Using rules for logarithms, we can bring this power down as a multiple or as a factor out in front. So we'll have the natural log of 2 is equal to t times the natural log of 1.06. Solve for t by dividing by the natural log of 1.06. So the natural log of 2 divided by the natural log of 1.06 is equal to t. We put that into our calculator, we'll get that t is approximately 12 years. So we can say that at 6% compounded annually, it will take roughly 12 years to double our initial investment, regardless of what the initial investment might be.